Hello everyone, this is Ashwin here. In this video, we are going to do a Kaggle project, that is Titanic survival prediction. So this is a machine learning project and it will come under classification problem. So this is like a basic project like everyone should try, similar to iris dataset. I thought of covering these things, so in order to cover all the main projects so that every beginner can able to easily understand the whole process. So currently I'm on the Kaggle website and I have already joined this competition. So this is like a practice problem. You can also see the dataset here. So the overview of the project is to predict the survival of a passenger in the Titanic. So this is the data overview. We have train.csv and test.csv. We're going to do all the training using the train.csv. It also includes training and validation, and finally, we are going to use the trained model to predict the test dataset results, and we will upload it to the Kaggle to see what is the score for us. So I'm going to go in a basic level. We are not going to do like hyperparameter tuning and all the complex stuff. So we will just do it later. So for now, we will analyze the dataset. What is there? Can we able to create new features? All the thing we will be seeing in this video. So here they have explained all those feature engineering techniques here. Let's see the dataset attributes. So these are the key variables that are in the dataset, that is train.data. So here we have survival. This is the output data we have to predict. Here we have 0 or 1, that is the key. And this is passenger class, that is the ticket class. We have 1, 2, 3, that is the level of the ticket, like upper level, lower level, something like that. And this is sex, that is gender, age in terms of years, siblings, number of siblings or spouses aboard the Titanic, and pash means parents and children aboard the Titanic. Ticket number is like similar to ID. I don't think it's like a useful attribute. We will check while doing the data analysis. And fare, this is like a ticket price, that is passenger fare. And cabin number, this is just a room number. Maybe we will try to get some inference for this also. And embarked, port of embarkation, this is Cherbourg, Queenstown and Southampton, and we will see it here. So for embarked, they don't have any detailed explanation for that. And so here they have explained all the variables with like detailed explanation. So here age is fractional. They already have like a pre-processed data, and here siblings represents to brother, sister, stepbrother, stepsister, spouses, husband and wife. Parents means mother, father. Child means daughter, son, stepdaughter, stepson. Some children traveled only with a nanny, therefore Pash is 0. So they have explained some inference about the data we are going to use, and these are the files we are going to use. Train.csv will be using so much for training, and this is the test CSV. We are going to use it for testing. And for gender submission, this is like a final result we have to submit to Kaggle in order to calculate our score. So this is the passenger ID and this is the survival column. So we have to figure that out whether the passenger is survived or not. Like this, we have to create a CSV file at the end. So that is our objective, and we can able to submit the predictions here. And also port of embarkation means from where it is leaving. So if the ship is leaving from this port means, so this is the place, it's so from this place the passenger is leaving, so like that it represents. And I already created a notebook. So if you want to create a notebook and use this data means go to code and click on this new notebook, and I already done it. So we will go to the notebook now, and this is the notebook. So they have already created some sample cell. You can able to run that. So you can able to run this. So these are all other attributes we can able to use. So if you expand the data, it's already having Titanic, and we can able to see all the data we have to process. And this is competitions, and we can also submit it here. And here we are having Python, internet connection is enabled. This is for using GPU and TPU, and I think everything is by default okay. We can close this and start our session. Now the session is starting with CPU. If you are using a deep learning project, means we can convert it to GPU or TPU, depends on the project. So after that we will run this code to see what are the directories and file names available. So this path we are going to use it for loading the dataset. So for first I'm going to load this train and test.csv. So I will create some new code cells so it will be easy for us. First we have to import modules. Now import pandas as pd, import numpy as np, import cbon as sns. So this is for visualization. Now import matplotlib.pyplot as plot, and I'll also import warnings. Usually there won't be any warnings, just to be in safe side, and also warnings dot filter warnings ignore, so it will ignore all the warnings. And apart from that we have to set matplotlib inline. Now these are the things. Let's run this once. So we have imported all the modules without any error. Now let's load the data. So for that, loading the dataset. Now let's load it. Df equals pd.read csv. I'm just going to call this as train. So what I'm going to do is combine both train and test data, so we can able to easily pre-process the data at single go, and we can able to split it. So that's how we usually do it for the competition. So it will be much easier to do the pre-processing. Now I'm going to copy the path, that is train.csv. So this is for training, and for test similarly we have to use the same code. This is test.csv. This submission file we can able to create it at the end, or else we can load it and change the data. So we will take care in the end. Now let's display train.head to check whether it is loaded. So it has loaded, and it also have some null values, as you can able to see here. And we have pretty much less number of values, like less number of attributes here for processing. I think it will be much easier for us to do the processing. Now let's describe the dataset. So I'm just going to process only for train. When we are doing the visualization or pre-processing, we will be combining the data. So now train.describe. Now these are some statistical information you can able to get from the data. So I'll call this as statistical info. You can see the total count of the data, that is 891, and here some of the data have missing values. That's why here we have less count. And we also have a range, that is 1 to 891. This is 0 and 1, and this is 1 to 3. That is the range. And this is 0.42 to 80. That's like a fraction. So I guess it's also including the months, I guess. So we will explore it later. And we have some minimum 0 to 8. That is the sibling count. This is for parents. That is for 0 to 6. And this is the ticket fare. So this is 0 to 512. I think it's in terms of dollars. so we don't have to worry about this. Now let's go to the next attribute. So this is data type info. So for this we can use train.info. So we have integer. Object means it represents some kind of string values. We have to convert the string values into integer. We will do that in the pre-processing step. And we also have float values. So totally we have around 12 columns with different data types, and also how many values we have, that also is displayed here. Here cabin have like so many null values, so we definitely have to drop this. Now I think that's it for like a overview of the data set. Before pre-processing, let's visualize the data set, so it will be easier. Without changing any null values, we can able to explore the data. I'll call this as exploratory data analysis. So you can do the pre-processing, and after that also you can do the exploratory data analysis. But sometimes we will do the pre-processing like using the mean. We will do the pre-processing means the graph will be somewhat different. So in order to avoid those differences, I'm just doing the visualization part before the pre-processing. Now first let's explore some categorical type. So first let's explore the output column. I'm just gonna use the train data for this, so it will be much easier. So this is for categorical attributes. Now SNS dot count plot df of train of survived. Let's run this. Now we can able to see for the column how the ratio is gonna be. So only around 350 persons are survived and remaining around 550 are dead. I think that's the case. And the data set is like not so much in the balanced state. You can also balance the data if you want, but that is like an advanced technique. We can do that later, or you can also see some of my previous videos to see that. Now I think for this data, the distribution is somewhat good, so we don't need to worry about the distribution. Let's go on to the next attribute. I'm just gonna copy and paste this so it will be easy. Now after that we can use the P class, passenger class, run this. Now here the passenger class also have like uneven distribution. First class and second class passengers having a equal distribution almost, and for the third class the count is much higher because so many people can't able to afford for higher range tickets. I think that's why the third class is like so much higher. Maybe depends on the class, the survival rate is also vary. We will explore that in detail. Now after P class name, we can't use that, so it's not that much meaningful attribute. We can go for sex, that is gender. Now this is the ratio, and the ratio is pretty uneven. That is from the total count of male, only half of them are female. Maybe you can assume apart from the family or the regular passengers, most of the workers will be male. That's why we are having this uneven distribution. But if we assume that is the scenario, means that persons may not considered as a passenger, and there won't be any fair price also for that passenger. So I think that's not the case. Maybe so many youngsters or other people are traveling for business purpose or some other purpose. That's why I think male are having higher ratio in the Titanic. So I think that's the assumption I am getting. So if you have any other assumptions, means you can leave a comment below. Now after that, age is like a continuous value, so we will use separate graph for that. And the next attribute will be siblings and parents and childs, so we will explore this. I think only 8 values are there. So okay, first we will go with the sp, siblings and spouse. So most of them are not having anyone like siblings or spouse, and the second is 1 or 2, so that is reasonable. I think this data is like so much biased to 0, that is not much dependable. And other categories are also less. 6 and 7 categories missing. I think that's odd, but some passenger having siblings or spouse around 8. Maybe that passenger has like so many siblings. And yeah, this is also like an uneven distribution, but yeah, it is acceptable. This one is represented by like mostly it will give inference for the spouse, so that's why one are having at least 200. 0 means others are all like solo passengers. Now parents and children, and here also we are having the same distribution, I guess. Here the values ranging from 0 to 6, so around 650 are solo, and here also around 600 are solo. And here we have 1 or 2. Here in the case we can have both children and parents, so in that case the 1 and 2 is like a optimal number. And is there anything left? So ticket fare is also a continuous value. Ticket, that is like a number. We will see. Yes, ticket is like a combined of string and number. We can drop this column. Fare, cabin we can't use. Embarked we can use, that is also a category. And the last one will be embarked. Now here in embarked we have 3 cities. From city S, I'm just gonna call it as yes because I don't know the city name, so you can refer the dataset overview for that. So majority of the people are coming from this city, and only few people are I think going from these 2 cities. Here also we can get the assumption that yes is the starting city that the ship departs, so that is also one assumption I can get. So I think we have covered all the category values now. We can able to get some pretty decent inference from it. Again, let's create some cells, and now for numerical values or numerical attributes, numerical attributes. So instead of count plot, I'm going to use dist plot in order to have a distribution plot. It will give us like a bell curve. Now train off, the first one is age. So here you can clearly see the histograms with the range varying. We definitely having a clear bell curve, that is uniform distribution, and majority of the passengers are in the range of 20 to 30, so that is the majority. And 60 to 80 are elderly people, and 0 to 10 is also like so much younger children. So the distribution is proper. I think we don't have to do any pre-processing for age. I'll just copy this and go to the next one. So survived, P class, age is done. Ticket is also an object, we can do this. Fare, we can use it. If you see all the numerical attributes, so age we have displayed, and yeah, only thing left is the fare. Let's see how the fare is gonna be, and it also doesn't have any null values, so that's good. Okay, now fare, run this. Now the fare is ranging around 0 to 500. Definitely we have to do some pre-processing here. And again, the fare is ranging from 0, and most of the fares are like 50 or 20. That is the range, and these are all some minority. So I guess we definitely have to do some pre-processing for the fare if you are including that into the training data. So we have to convert this right skewed graph into a uniform bell curve like this. So that is important. And you can also consider these fares are like third class ticket. So higher the class, the ticket cost is also higher. That's why we are having this. So in order to find some detailed analysis, I will create one more additional graph. So that will be very helpful to compare the ticket class and the price. So it will be helpful for the beginners. So I'm going to use a pivot table function. I will say class fare equals train dot pivot table. Now you have to specify the index. Index equals, I think that is p class. I really don't know the exact. Okay, p class, I think that's correct. Yes, and this is the index, and values will be our fare. So I will call it as fare, and by default it will do a mean of all the values for the particular class. So that's how the pivot table will work. Now I'm going to plot this table. So it will actually return a table. Now plot kind will be bar plot, and we can also set a figure size, but we don't need it. Let's also plot the x-axis and y-axis. So here we have some x-axis and y-axis, right? Similarly, we will plot that. So plot dot x label. So in the x-axis we'll be having passenger class, and again plot dot y label. Let's go down a little. Y label will be fare, or you can call it as average fare. So average fare. So we can also set the title. Before that, we can just show the graph. Let's run this. Now, okay, the class is like pretty messed up, so I'll just fix that. Now plot dot xticks rotation equals 90 degree, and this, okay, that is already in 90 degrees, so 0 degree. Now you can able to see the class clearly, and you can also see the ranges of the corresponding pair. So I think this is the comparison. So this is first class, second class, and the third class. So here you can able to see the average price of the first class ticket is so much higher compared to the third class ticket. That's why we are having like so much values in the 0 to $50. That's why we are having the bell curve here, and this average fare is like much higher. That's why the first class tickets are like so much costlier. I think it's in the range of 300 to 500. It depends. And let's also try to do one more graph instead of mean. So I'm going to set the aggregation function equals np dot sum. So I can say it as total fare. Now here also you can able to see a difference between the total cost of the first class, that's around $17,500, and for the third class it's around 5500, and for the second class it's around 2000 or 3000. So this is another visualization you can do, and you can also add a title if you want. You just have to write plot.title and the title like this, and you can able to have a title for this graph. So from these graphs we can able to observe how the data set is varying depends on the particular class. So this is like one kind of example you can use. So that concludes our exploratory data analysis. So for visualization it is done. In the pre-processing we'll be doing few things. First thing, we have to delete some columns and remove some null values. Now let's go for data pre-processing. Now the first step will be finding the null values. Find the null values. So before doing this, we can combine both the train and test data, so it will be easier for us. So first we will have the train data set length. So I will call it as train length equals length of train data frame. Now combine two data frame, that is train and test. So I will have df equals pd dot concat the data frame list, that is train and test. We have to specify the axis equals 0. 0 means it will concatenate in row wise. 1 means it will concatenate in kind of column wise. It will add more columns like that. So we will be having row wise, and yeah, I think that will be enough, and we will display the data. So we have the data frame here. So this is the top 5. If you want to see the bottom 5, df dot tail. So this contains the last 5, and here also see you can see the index. This is for the test data, so we can reset the index, so it will be easier. Df dot reset index. So df dot reset index, and we have to store it in the data frame. Let's run this once and this again. Now you can able to see the clear difference of the count. If you see the length of the data, train length, so we have 891, that is the training data set length, and we have appended more data, that is around 490, I guess, that is the test data we have appended into like a single data frame. We can delete this. Okay, and this is the tail data. Here in the tail data you can clearly see the survived column having null values. So we will drop that later when we are doing the processing. So anyway, we have to drop the null values in the data set. Now we will find the null values now. Df dot is null dot sum. So it will count the number of null values for each column. So now you can see this is survived. This is the test data set length, so we should not worry about this column. And apart from that, we have null values for the age. So we can find the mean of the age and fill it with the null values. So that is one way. And for cabin, we are having so many null values. Out of 1300, 1000 are missing. So we will drop this column. And for other two, fare and embarked, also they are having 1 missing value and 2 missing value. We will fill that using mean and mode. So that's an easy way. Now first let's drop the column cabin. So df equals, so drop or delete the column. So for that, df dot drop columns equals we just have to drop one column. So I will specify cabin, and also you have to specify the axis. So that is 1. We have to delete the whole column, and this will delete this, and it will be done. So after that, we are having age. We will fill the missing value of age using mean. So how we are going to do that? Fill missing values using mean of that column. So for two numerical values, we can use mean. So one is age and the other one is fair. For that, df of age equals df of age dot fill na, that is fill null values. You can fill it with df of age dot mean. So first, let us display the mean value of age, and this. So this is the mean, and we are going to fill this value in this particular column. That's how it works. So I'll just leave this as reference, and we are going to do the same for ticket fare. So fare with capital F. Now paste this. We are going to fill both of these null values using mean. Run this. Now it's done. Now similarly, we have to use mode in order to fill these null values. So that is embarked. And yeah, I think we have to only fill the null values for embarked. I'm going to use mode for that. Let's display how the mode works. Embarked dot mode. So it's actually returning us an object. We just have to use this yes only. So for that, I'm going to use the index 0. Now I'm just having the corresponding city. I'm just going to fill. So this is easier way. Now similarly, just copy and paste this. Here we are going to use embarked, paste. Now instead of this mean, we are going to fill this with mode. Why we are filling this with mode? Because this is a categorical value. So fill missing values using mean of that column for of that numerical column. Now similarly, we'll be having fill missing values using mode of the categorical column. So I think we have filled the missing values. So the basic pre-processing has been done, that is removing all the null values, and after that we can reformat the data a little. I already mentioned for one column we have to balance the data, that is this column. For fare, the curve is not uniformed, so we have to convert this. I'm going to copy this to see the difference. I'm going to use log transformation for this. So I will create a markdown, log transformation for uniform distribution, for uniform data distribution. Now run this. Let's paste it now. Now this is the graph we are having. Now let's do the log transformation. So this is for training data. That is fine. We can also use the whole data for this. Still it remains the same. Now df of fare equals np dot log of df of fare plus 1. So usually we have to add plus 1 when we are using logarithmic functions. Whenever a fare is 0 or some null values, it will throw an error. That's why to avoid these errors, we can have plus 1 to this values, so it won't affect the data that much. Now let's run this once. Now run the same again. Now you can able to see at least the distribution has changed. Now this is a right skewed graph, so it's the whole graph is in the left side. Now here in this graph, it is going in the uniform distribution, not like a perfect uniform like we have seen in the age, but the bell is in the center of the graph. So that's a good start we can do. And I think we are having some zeros. I think some number of zeros are there, and minus values is also there. I think we have to check on that. I think for now it's not an issue. We can proceed further after that we have uniformed the data properly. So after doing the log transformation, we can do a correlation matrix. So correlation matrix. With this matrix, we can able to clearly see which input attributes affects the column. So that's the purpose of this. So let's create a correlation matrix quickly. So this will return a matrix for us. And plot dot figure. I'm just changing the size, so it will be bigger for us. Just going for 15, 9. We can also adjust the values later. SNS dot heat map. So this is for displaying the correlation matrix. The correlation matrix annotation equals true to display the matrix values, and color map CMap equals, I will usually use cool warm to clearly differentiate between highly correlated attributes. Now we can able to see all the things here, and we are also having index. I think we have to drop it. Here we do have the index. I think we don't need that. Drop equals true. Let's run this. Now the index has been dropped. That's good for us. Now let's run these things once again. Okay. Yeah, now it's fine. Now we will generally see what are the correlation between attributes whenever we are having like dark colors like this red color or this dark blue color. We are having high correlation, so we don't need to consider this diagonal values. So all are 1 because all are same values, passenger ID and passenger ID. That's why it's having 1. We will just see any one of the triangle. This is upper triangle and lower triangle. So we will see the lower triangle. So in this triangle, we can able to see the fare has a negative correlation with the passenger class. I already explained with some attributes before, like using the visualization, we can able to see the difference. And by also using common sense, we can clearly have a relation between these two attributes. That's why it's having impact. And it is also having some reasonable impact on the output class. So this is one of the important attributes, I guess. And we also done the uniformity using a log transformation. So that's also a plus for us. And here also the passenger class is important for survival. Using this correlation matrix itself, we can clearly observe that the passenger class and the fare, like that is more important. I don't know whether it is positively impacting or negatively impacting. So that also we have to explore it. So we can have a visualization for that. And for other attributes, there is not much correlation. Everything is like normal color, and here we have some correlation between parents children and siblings children. We have like some correlation, and the fare is also having correlation with the every attribute: survived, p class, age, siblings and spouse, parents and children, all of them having correlation. So fare is like an important attribute for us that determines the class of the passenger. Higher the fare, higher the class. So simple as that. So this is the correlation matrix. So I'll try to display this difference between the passenger class and the survival. So I can do that in the exploratory. So at the bottom I'll do. So SNS dot bar plot data equals, we'll be using train data here, and we have to specify the x-axis. So x-axis will be passenger class, and we are having hue equals survived. Let's run this once to check whether it is working or not. So it's not working. Hue is survived. We will specify the y-axis too. Y equals fare. Now based on the fare and the passenger class, we are having this graph. So here in the first class, like so many people are survived, around 100, and like half of them are not survived. And here also we are having equal distribution of survival and not survival. I guess it also plays a major role, like so many people are survived in the first class, only a few of them are surviving. So this is based on the fare. That's why we are not getting the detailed report or inference. So this is also another way to do a bar plot or a different kind of plot. So you can also explore other plots if you want. Maybe I'll just change the attribute a little. So here instead of p class, I'm going to use survived. Hue will be p class. Let's see the difference. I think here both the graph are like same, but with the different x-axis. So this is like a different way of inference. You can use it for any other data set. And yeah, we will go to the next step. So we have done the correlation matrix and observe some difference. So we will go to the next step. Before that, we will see the data. What are the things we have? So in general, we are having passenger ID, but we can't use that for the training. So this column is useless. And name is also not important attribute because we can't convert that name into anything meaningful. So we will be dropping that, and we have to convert this string mail into some number 0 or 1. And here the ticket number is also not much meaningful, so we have to drop this. And here for embarked, here also we have to convert this into a integer, so we can do the processing. So now let's drop few columns. So drop unnecessary columns. Now we already know the command df of drop columns equals. So we are going to drop the name. So we will be dropping the passenger ID in the end because we have to use the passenger ID for the submission. That's why I'm just keeping it for temporary basis. So name we are going to drop ticket, and axis equals 1. So this will drop these two columns. Now that's good. Next, we are going to convert this sex and embarked into integers. We are going to use label encoding. Before that, I will leave some space. Label encoding. For that, we have to import a module from sklearn.preprocessing import label encoder. So this is the module, and we can also specify the columns we have to convert. So that will be this one and this one. So this will be easier for processing, and we have to initialize label encoding. LE equals label encoder. Now we will do the processing. For column in calls df of column equals le dot fit transform. I'm just training it and transforming the data into integers. We have to transform that particular column. So this will be done, and after that, let's show the result. We are having an error. Okay, this is not a string, this is a variable. Run this. Yes, we have converted both of these columns into numerical attributes, so we can able to do the processing. So all the pre-processing steps and the exploratory steps are done. Now here male is converted into 1, female is converted into 0, and here also each city is converted into some number. So that's good. Now we have to split the data set for training and validation. So now we have to do a data split for training and validation. So I will call it as train test split, because we are going to use a module similar to that. Before that, we have to split the data for training and for testing in general. So that will be train equals df of iloc equals, I will get until the train length that I have stored. So this is will get all the columns that is in the data set, and this will get until this row that is up to the train length. So this is for training data, and for testing data we are starting from train length till the end of the data we'll be getting. So let's run this. Now that's done. Train dot head. So we have all the data. Now test dot head. Now you can able to see these things are survived column is having null values, so that we don't need to worry. We will drop it later anyway. Now let's do the actual train and test split. Like for input split, I will call it as input split. So input attributes will be stored in the x variable. Now df dot drop. We are just dropping the unnecessary columns here. We have to drop columns equals the passenger ID, that is not at all useful for us, and we have to drop the output column too. So that will be passenger ID. So I'll just copy and paste this, and survived, copy and paste this. So these two things are done, and yeah, we have to specify the axis equals 1, and for the output, that is y, I will just use the survived column directly, df of survived. Okay, I just use df. We have to use train, not df. So this is the input. Now that's done. We are having all the input attributes in X and Y having the output attribute. Let's also display the attributes so you can able to clearly understand what is there inside. So these are the input attributes we are going to use. So that's clear for us. Let's go for the model training. So I will create some cells so it will be easy for us. Create a markdown, model training. I'm just gonna use a few models for us in order for exploration. So I'm going to create a classify function here so we can able to reuse the function later. Now def classify, I'll be passing the model, input and output. So this is the case. Now inside the classify we are going to split the input for training and testing, like training and validation. I will import the module here from sklearn dot model selection import train test split. So using this we are going to split the data. So x train, x test, y train and y test. Train test split, train test split. So we'll be passing the input, output, test size, that is the validation size. I'll be splitting it with 25% of data and random state. So whenever it's splitting, it will split in the uniform way. I will mention 42. You just have to specify some number. So this will having the training data input and this will have the training data output. Just keep in mind X represents the input and Y represents the output. So this is for training and this is for testing and validation. And don't confuse with the actual test data. We are not even touching it. We are just going to touch that in the end for submitting the results. Now after splitting the data, we will train the model. So model.fit x underscore train comma y underscore train. So we are just training the model. And after that we will print the accuracy. Just have it. And for that we have to import another module. Okay, I think we can use the inbuilt module in model itself. Model.score x underscore test. So we are just checking with the testing data we got. So it will compare, it will try to predict from the test data and compare with the test result. So it will be easy to find the accuracy of the model. And after that we are going to do another validation, that is cross validation. So for that I'm going to import another module, cross val score. So this is like a standard thing I use for every project. So cross val score, again pass the model, input and output. Here cross validation size can be 5. So it will split the data into 5 folds and train it with 4 parts of the data and test with 1 part of the data. Like that it will do it for 5 times. Again we will print the score, like I will call it as CV score comma np dot mean. I'm just taking the average of the 5 scores. It will give a 5 score result. I will pass the score here. Yeah, that's done. Let's run this. Now let's go for the actual training with the actual model. First I'm going to go with the simple model. So from sklearn.linear model, import logistic regression. So this is a classification model. So model equals logistic regression. Now we will call the function classify equals model comma x comma y. Let's run this. Okay, now here I think we are having some error. So we are having around 80% accuracy with the training and testing. So here I think we are getting some error. Just check what is it. Okay, for one thing we are having null values. Okay, I guess we are already having this x and y attribute. We don't have to pass it every time. We will just pass the model alone. So we can use the x and y as like this. So we will remove all these things. I don't know why it's showing null values for logistic regression. Maybe let's check it out for one more model and see whether it is reflecting again. Usually it won't work like this. So it will having 5 values, like similar to these values. It should have another value here. I will use some other model now to check. So from sklearn.tree import decision tree classifier, and we are going to use the same here. Just change the model name. Run this. See, it is actually working here. For logistic regression only, it's not working. So I'll just remove this. We'll just leave this for the logistic regression and run this once, run this once. So this is 80, and here we are having 73 accuracy, and in the cross validation score we are having around 76.5. So that's reasonable for us. So similarly we will try to import some other modules and check which one having a higher score. So I'm just going to import it quickly from sklearn.ensemble import random forest classifier, and the same thing, random forest classifier. So here we are having the cross validation score around 80.9. So currently it's in the decimal point. You just have to multiply it by 100 in order to get it as like a percentage. So we will just convert it in our mind. Now usually accuracy is determined based on the test data we are splitting here, and cross validation is determined by different kinds of training data and testing data. So it will be splitting it by 5 folds. I just deleted it. So I just having it again. So run this, run this, run this. Now if I go for 5 folds, it's having 81. So it's actually a better way to do. And usually when you are comparing the model, make sure you use the cross validation score. This is like a good metric to compare the model. That's why I use it for all the projects. Okay, our highest score is like 81.5. Let's go for some other models. So I usually use extra trees also. So from ensemble we are going to have extra trees classifier. Run this. Okay, this is around 79. Okay, apart from that we have XGBoost. That is also one of the good models. Maybe from XGBoost import XGB classifier. Copy and paste the same thing. XGB classifier. Okay, Currently we are having the accuracy around 78.9 and the cross validation is around 81.2. Okay, it's almost equal to random forest. Let's try our luck with another model. So let's use light GBM. From light GBM, import LGBM classifier. Now paste it, LGBM classifier, run this. Wow, we have got more cross validation score here, 82.38, that is higher than random forest. Now I'm just going to use the last model in my arsenal. So from cat boost, import cat boost classifier. So this is the last one I have. After that we will pick the best model. Now cat boost classifier, it's actually going like a deep learning. In order to avoid this, you just have to pass verbose equals 0. Let's run this again. Wow, it's having the accuracy around 82.95 and yeah, in the cross validation score it's having 82.26. It is slightly less than the light GBM. So I guess we will be going with light GBM alone because I'm just considering the cross validation score. So these are all model training and validation. So after doing this, we have to train it with the full data. Complete model training with full data. Full data. Now for this, I'm going to use this light GBM module. GBM. Now I am going to train it with the whole data. So model.fit x and y. This is the whole data I'm going to train. Okay, it just trained the model. Before that, we are using x train and y train here for training, and for cross validation it also splits the data in 5 folds. Now when we are trying to submit the model, we have to train it with full data. So we have done it, and now we have to use the test data we had. So this is the test data. We have to predict this survived column. Now we have to again get the x and y columns from the test data, similar to above, like here. Input let for test data, I will call it as x underscore test, and we don't need the y because we just have to find that, so we don't need it. Now this is done. Let's check. Now we are having the same input attributes as the training data we had here. So make sure you align with this same number of columns. And now we are going to do the prediction. So prediction equals model dot predict x underscore test. So this will give you the prediction results. I'm just going to show you here. Now these are the prediction results we are having. So after this, I'm just going to store the prediction results in the test data frame. Okay, I just messed up here. Here we have to have the test. Run this. It's same now. Now let's predict it. Now it's good. Now I'm going to store this result in the survived column, and after that we will just have this passenger ID and survived column, or else we can create a new data frame, so that is also easier. So This is test submission. We are at the last part of this project. We are going to submit the results we have predicted. So for that, I'm going to have submission equals pd.readCSV. As I already mentioned, we do have some submission template with us. That is this gender submission CSV. We can use this format. Now let's do the submission.head. Let's see what is there inside. Now we are having the passenger ID and the survived. So we just need to go change this survived to the prediction we had. So for that, sub of survived equals the prediction that we had. Run this. Now this is the submission we are having. See, now we have completed all those things. We have completed the prediction. Now we have to submit the file to the competition. So I'm going to save this file. So sub.toCSV. I will call this as submission.csv and index equals false. So this index equals false means it will drop this index and save these two columns only. So let's run this. Now we have stored the results here in the submission. Now in the competition we can submit. So submit notebook 1. This is version 1. And we have to check whether we have to store it in a different way. So for now I'm just submitting. Let's see what will happen. So I think for submission we have to see what is the procedure. So this is data, submit prediction, we can do it. Overview, make a submission, upload your prediction as a submission on Kaggle and receive an accuracy score. So this is the step we are currently in, and how to submit your predictions. So you can submit the file as it is, submission file format, that we need to have 2 columns. We already did that. So we can submit here. Let's go to the tab. Currently it's running. Okay. So the submission, it's saying the submission is successful. I don't know whether we have to save it in the same file or not. So it's showing it's successful. Let's check the leaderboard once. Are we in the leaderboard? Okay, so we are currently at the last. I think we didn't do the submission properly. They are having score 100%. That means 100% accuracy. So that also you can get if you do hyperparameter tuning and create some new attributes from the attributes we have, like from the input attributes. Okay, now, okay, I just figured out what is the issue. Currently the values are in the float format. We just have to convert it into a integer. Let's check. So after this I will say sub of survived equals submission of survived dot as type equals int. So before that we will check what is the format is there. So sub.info. So currently it's in the integer and float 64. That's why our submission failed. Now after doing this, we can check the format. Now both are integer. Now again let's submit it and save the submission. Again I'm going to do a submission. It will take some time. So as you can able to see, it's actually running the whole notebook again. You can see the difference here, and after that finally it will submit the submission file we have. So I will just wait for, I think it's writing now. Now the submission is successful. Scoring is also complete. Okay, I'll just dismiss this and go to the leaderboard. Jump to your position on the leaderboard. Now we are at the 13,000 position. So we are having the score around 75%. And you can see a lot more difference here. If you just have like 1.1 more, means you will be jumping to so many positions higher. And I didn't do any kind of hyperparameter tuning or any other creation of new attributes here. If you do that, you can clearly get into the first score, that is the 100% accuracy. You can easily get it with this data set. So far we have done all the basic things. This is like a baseline code you can have with basic analytics, and try to create some more attributes from this, and try to find a pattern to get the survived column correctly. So that is the objective. So I think that's it, guys. We have completed a lot of things in a single video. I think I have covered all the basic stuff, and some of the advanced stuff I already mentioned it in some of the previous videos. You can refer that and try to incorporate those things here, and you can do a lot of other techniques on top of this basic training and testing. So you can use this notebook as a baseline model, and after that you can add some of your own techniques and submit the prediction. That's how it is works. And I think even if I add more things, means definitely my score will increase a lot. So yeah, I think maybe I can cover that in next video. And if you are attended this contest, and if you have tried some other techniques that improve the score, this is the baseline score 75119. If you improved it further, means just leave a comment so everyone can able to learn from your experience and try to implement it. It will be very helpful for the community. And that's it, guys. Stay tuned for the new project.